Good afternoon, everybody. Paul Rossi here, founder and COO of 910 Drones. Appreciate you tuning in today. We're going to be jumping into a drones and power transmission and distribution discussion. This webinar this afternoon is in partnership with the North Carolina Department of Public Instruction. So we're putting this information out to our high school educators that are implementing a Part 107 course, as well as a second course that goes into mapping and modeling and more of the operations of a drone pilot. So we're letting people trickle in here, but as mentioned, power transmission and distribution is our topic today, is our main discussion. The topics that we are going to cover is how electric and utility companies are leveraging unmanned systems. What hardware and software are they leveraging? And then we'll get into a discussion regarding the current and future career pathways and kind of what skills companies look for in new hires. So without further ado, I'm going to get out of my own way because you guys, some of you that tuned into yesterday's event, heard enough from me. What I want to do is bring on each of our panelists one at a time. Of course, I'm going to ask, first I'm going to ask Corey Hitchcock with Georgia Power to come on and join us. Introduce yourself.
There, now we're fixed.
Hey, we're good. We're good to go.
Well, here we go. Thanks, Corona. But I'm Corey Hitchcock. I'm the senior standardization or chief drone pilot for Southern Company. I'm responsible for all the use case development, process and procedure development, and safety management system development at Southern Company. Been there about 20 years. I came from a kind of a line work background, transmission and line construction background. Spent some time in the Army where I was exposed to UAS and immediately saw the benefit as it applies to our business. When I was medically retired in 2014 and then came back to work at Southern Company and have been working in the drone space at Southern since 2015. So I'm happy to be here and happy to answer any questions, and I hope you guys can learn something from what I have today.
Excellent. Thank you very much, Corey. I'm going to put you back on hold. And I want to bring in Garrett Scott with Duke Energy. And can you go ahead, Garrett, start your video here and introduce yourself? Garrett?
Hello, sir.
How are you doing, Garrett? Can you just introduce yourself? Just tell us a little about how Duke Energy is leveraging UAS, or not really leveraging UAS, but just tell us a little about yourself and Duke Energy.
Sure, yeah. So my name's Garrett Scott with Duke Energy. I sit here in Charlotte, North Carolina at the aviation facility at the Charlotte Airport. And I am the UAS coordinator for the company. Duke leverages really UAS for pretty much every use case that's out there right now. Everything from just general data collection to flying inside of voids, confined space, to string pulling. So we have a team here that does enterprise operations throughout the company, and then we also have a fairly large project right now that's based around customer delivery operations and distribution, GIS collection.
Excellent. Awesome, Garrett. Thank you very much for joining us. And I'm going to go ahead and then I'll put you on hold. I'm going to bring in our last panelist, John Lassiter. John Lassiter is with Halifax EMC here in North Carolina. So John, I'm asking you now to start your video. There we go. How you doing, John? Just go ahead and introduce yourself and tell us a little about Halifax.
How you doing? I'm John Lassiter. I'm with Halifax Electric in Enfield, North Carolina. I was a lineman for 16 years and been doing substation and meter work for the last 4. And we used the drone for various applications.
Excellent. Thank you, John. I'm now going to bring on all three of us, Corey and Garrett. And to start out, we'll just move a little bit into a kind of deeper discussion of how each organization is leveraging drones. And if there's any like use case, current example, like Garrett, you mentioned some current operations that you can kind of discuss and how these are, I'd say, relevant from an educational standpoint for, say, students and implementing, you know, for instructors to know about operations. Can you start off, Garrett?
Sure. I'd say probably the biggest one for us and the one that I'm probably most interested in having received quite a bit of training in it is some of the work that we do with thermography at Duke. We do a lot of work for our fossil hydro business units, and really that work is centered around trying to use drone technology and thermography specifically to look at solar panels. And we do a lot of work with thermal cameras and to collect manual data and automated data where we're flying the drone using a program and then sending that data through proprietary programs to try to find small faults in the panels. And really we do that for efficiency purposes and to try to have an understanding of how much of the site is working at any given time. And there's a lot of educational need there to be able to do that kind of work. You have to have a pretty good understanding of the science of how those cameras work to really make the most use of that. So that's definitely something that's more.
So kind of, you mentioned the solar panels. In one of the schools locally, Scotland High School, that I've worked with to help them do more with drones, right behind their football field, they have a solar field. So what you're kind of saying is introducing students, especially within high school, to get that thermal camera and have them start to understand whether it's emissivity, and then maybe even if it's just the palettes, like understanding different thermal palettes, that would help a Part 107 operator that's coming into maybe the program. So did you want to add anything to that, or?
Yeah, and I would say even at a more fundamental level, thermography is really based in the thermal sciences, understanding different types of heat transfer, understanding, what does a thermal camera actually see? It doesn't see heat, it sees energy. It sees energy being absorbed, energy being emitted. And so kind of starting at that very fundamental level of, understanding, you can really tie that in even at a low level in science and grade school to some of those heat transfer sciences, and that's really critical knowledge when it comes to thermography.
Yeah, I would say I learned about, the joules, I think, in the way heat transfers, but never was even through college kind of introduced to thermal and heat transfer through a thermal imager. I want to go to John, because John, speaking of the thermal imaging, what is it that Halifax, or how is Halifax leveraging the thermal imagery within their operations?
Well, we fly every one of our substations. We try to do it once a month or once every other month, checking for hot spots, and on all our switches, all our connections on our transformers, transmission connections, and even some large banks that we got feeding sawmills or our big industries. We fly all them and check for any hot spots on their connections on their transformer banks.
And how were you checking these before you used the drone? Is there any time or efficiency that the drone brought in?
Where you had handhelds that you used, and I mean, it was at a certain distance you could only get. You'd have to get a bucket. Transmission was really pointless. but we can cover a whole lot more territory, and I can do probably 10 stations a day.
Wow, that's pretty significant. So before, what would you say before drone? How many substations could you do a day?
Oh, it take the whole week.
A whole week. Okay, so that's pretty excellent. Corey, kind of kick it over to you. If you can tell us about current operations, how is it that Georgia Power is leveraging UAS, and if it's to a thermal extent or not thermal.
Well, at Southern, we're doing a lot with
Southern. Sorry.
Yeah, well, that's okay. Southern Company is Georgia Power and Alabama Power and Mississippi Power.
Okay.
At Southern, we are really using drones all across our fleet for things that we didn't know we were going to use drones for when we started. Mapping has probably been our fastest growing use case. So we're using drones to do a lot of ortho mosaic mapping using drone deploy software and sometimes Pix4D. But with that mapping, we're also creating 3D models of assets so that we can virtually inspect assets. I know you said we could share some stuff. I have a quick example of one of those projects that we've done. If now's the time.
Oh, now's the time.
Okay, cool. All right, so let me share this with you. This is an example of a 3D model that we built to investigate a parabolic cooling tower. So the problem that the engineers had was that this cooling tower, which you'll recognize what it is in just a second, was they were finding concrete around this base of the cooling tower. So so with that, hold on, let me get my little laser pointer out here. There we go. Nope. Hold on a minute.
Hit him with the laser.
There it is. Got the laser beam. All right. So so this is the bottom apron or the lower apron of the structure, and we're looking at the top down of a parabolic cooling tower. So I'm going to transfer over to I'm going to transfer over and show you guys what our 3D model looks like. So the idea was that they really have a very hard time inspecting this due to the fact that come on, load Corona, don't fail me now. All right, there it is. Okay, so so they have a really hard time inspecting this. This cooling tower is 500 feet tall, and we really didn't have a good way to do it other than send a person climbing a ladder that's attached to the side of this thing all the way to the top. They tie a rope up at the top and then rappel down it and look at every inch of the structure. So,
and they're climbing up the ladder from the inside?
No, from the outside, I believe. There may be a ladder on the inside of this one. I think the ladder that I was talking about was on the outside.
Okay.
But what we did is we flew a Phantom 4, a drone that a lot of people have. It's pretty ubiquitous. We flew it manually around the structure over 3 days and captured 1,552 photos. And the photos that we captured were then input into the software, which created this 3D model. This 3D model has enough resolution that we're able to determine and see oops, I moved it too fast. Sorry, hold on.
And I think if you click that settings, right, isn't that the standard definition we're looking at on the right?
It is, but I don't think it would load if we
load up, yeah,
because of the bandwidth issues. But something I want to show you is that you can click inspect, and we tap the inspect button, and we tap on the screen, and it picks the picture out that captured that defect. So the defect you see here is exposed rebar, and then that picture is then displayed in full resolution. So this is the full resolution that the picture was able to get. We can move in here and sorry about that. We can move in here, identify what we call as our problem. We've got two defects here. We've got some exposed rebar there. We've got some exposed rebar over here and a little bit right here. So what we want to do is make an issue of it. So we draw a little box around it, and then we call it, we'll call it a crack, and we'll say test, and then we'll save that. And now when we go back to our model, everything works right, that defect is there. and then we can click on that defect, and it should show us. Well, that's a different section. It may take a minute to upload, but that's how we inspect these large objects.
Yeah.
So that's probably our biggest use case. Saved us about $800,000 just for the inspection by being able to do this. We've actually even 3D printed this model in color, so we've got a 2-foot version of this sitting on the boss's desk, which is pretty cool.
You're teeing up tomorrow's webinar for the DPI, because we're doing mapping and modeling. So
oh, cool, yeah.
Yeah, this is great. And what you said, which is a really good thing to point, was this was captured manually. So while
while
these softwares have that capability to be, autonomous capture, when you're inspecting something like that stack, you've got to put it into some manual mode, right? So the piloting skills are required. And then what we can kind of roll into is hardware and software, because you just teed that up really well, Corey. Just going to have you on all the webinars. You mentioned the Phantom 4 Pro, right? So you use Phantom 4 Pro, which has the 20 megapixel sensor.
Does?
Yeah, well, when you're looking at it in the world of the drones, it's not a highly expensive piece of equipment, right?
No, it's not. It's only
a $1,500-$1,600 drone.
Right.
To capture that many pictures, you're looking at $200 a battery. So you're under $3,000. You're capturing visual imagery, and that's the hardware you're using, which is not. It's not like $50,000 drone tech. This is the same we have. I'll go to Douglas Byrd High School, which is one of the other high schools that I'm working with. They have 2 Phantom 4 Pros, right? So they have that same exact equipment that Southern Company is leveraging to fly and collect data. And then software, right? We're taking these pictures because they have the GPS location and loading that into some software. So if you want to, Corey, is this another different project or?
This is.
And what I want to say is we're rolling into software. We're using mapping and modeling software, and just go ahead.
Okay, so this is an example of a map that we've done. This was done with a little bit different camera, but like you said, you can do this with you do smaller areas with a, Phantom, Mavic, any of those aircraft are totally capable of doing mapping and kind of showing how mapping works. But basically, we used an automated program, and we're able to fly a grid pattern over our new nuclear plants that are under construction right now. So this is Reactor Unit 3 and Reactor Unit 4 that are being built at Plant Vogtle. So each dot you see is representative of a photo that was taken. The difference in this camera and the Phantom, this was a 100 megapixel camera on phase 1. But I just want to kind of show you the level of detail we were able to get. We flew this from 600 feet, and everybody knows what a F-350 and a person in a hard hat looks like. So this is a picture of us. This is our crew working, and this is a little generator, 5-gallon water can, 5-gallon gas can, and that's the kind of resolution we're able to get from 600 feet. So we can get.
And now can you say the platform that you used once, just so that maybe the folks
sure.
tuning in can take note of that?
Software or hardware?
The hardware.
Oh, hardware. Yeah, we were flying the phase 1 100 megapixel camera on a DJI M600 drone. It's a hexacopter type drone. And this is a view inside the actual reactor space. This is where the reactor the reactor's underneath here. These are steam water generators, or I think steam generators they're called. And but this is what inside the reactor space would look like. Everything inside here is inside the containment at the reactor.
Excellent. Now
back to you.
Yeah, thank you, Corey. Thank you, Corey. We talked about the Phantom 4 Pro, so I'm going to roll over to John. John, can you tell us about the hardware and any software that you might be leveraging to do those different substation inspections that you mentioned?
We use the Phantom 4 Pro, but we had one modified where we got a FLIR camera on it with a battery pack.
And how long ago did you have it modified? Or did you get it?
It was when before they even started putting thermal imaging on drones.
Yeah, so you've been doing this for, I think you said 4 years.
Mm-hmm.
Okay, and then you can just tell us about that Phantom 4 Pro.
Yeah, we had a company out of Raleigh, put one together for us, and I mean it's pretty basic. It's the job done. It's mounted on the side. You can adjust it manually, but not in flight. And you can also change the pilots on the thermal cameras. The thermal imaging on that FLIR is nice, but
which is great because for a while, you before the capability, you've been able to improvise, adapt it, and kind of overcome in order to get this imagery. You with Halifax is using what you can to get that data. The point there is with the schools, they might not have all that same equipment, but there's still ways to accomplish. And I think, John, that you've seen the current equipment when you and I got to fly together. So I would say, if you could just speak to how far the equipment has come from what you've seen over just a 4-year time.
Oh, 100% different. I mean, it's totally different. I mean, this can be thrown together by anybody, the one I have, and you have to use 2 different screens, you know.
Right.
And just the interaction between one screen that you had on the Maverick is 100 times better.
Yeah. So in this short 4-year period, we've seen great strides made in that equipment. And then software-wise, John, I know when we had connected, I think FLIR tools was something you had mentioned that you might have been leveraging, or.
Well, we just used I used the FLIR software where I can tell the temperature, you know, certain switches, or we fly solar fields too, on different panels. And we don't use much software with that. Nothing like Corey's got going on there.
Yeah. Well, you can get into that, especially with especially with the platform you got. You got the right drone for the mission. So how about Garrett? Can you tell us about the hardware and any software solutions that you might be leveraging?
Yeah, so we use some of the same things that we've been talking about here. We're not in the Phantom business right now, but we use the 600s with the phase 1s. You know, Mavics are great entry level for pretty much anything that you want to try to do. You know, and we have a lot of different aircraft within Duke Energy for void inspections, and so the hardware, there's a lot of different hardware options that are out there. Some more expensive, some are, you know, a lot less expensive. It's kind of just what you're trying to do. A lot of the thermography type stuff that we do, the sensors that we use are you know, larger sensors, higher resolution, IR and EO, or IR only. But speaking to that software piece, you know, I saw Corey's using Drone Deploy. You know, we use kind of the base of that in a lot of these mapping softwares, which is Pix4D, and that, you know, that's something that it requires a little bit more tinkering with, and it's not quite as intuitive as being able to send that data in and have it processed and kind of get that polished interface out of it. But it is very good for, you know, some of these the larger missions. We've done some mapping as well with the phase 1, and you know, the Pix4D works out very well for us on that. So
yeah, you mentioned the Mavic 2, and I know Duke Energy just before the end of last year and really rolling into this year was kind of hiring pilots here in the state. And from what I could tell, the Mavic 2 was the aircraft that folks were kind of rolling out with. So because again, the Mavic 2 is a platform that these instructors have right at their schools. So what kinds of things are being done with that Mavic 2?
Sure, we're still hiring people for that project. It's essentially a project where we're collecting data on distribution assets And that's all has to do with updating GIS information and making the grid more resilient. And we're hiring, you know, kids and adults from pretty much every walk of life. Some of them with college backgrounds, some of them, we have a retired state trooper that's working for us on that project right now. So there's really a mix of different people. But that Mavic, you know, is really used because it's a relatively easy aircraft to fly. It's intuitive. It has a good sensor on it, 20 megapixels. And it's a small footprint, and we're doing a lot of work in and around, you know, people's homes and in areas where we don't want to fly a really large drone. We want to be able to have that smaller footprint. So.
And I think a huge thing about that Mavic 2 Pro is you get the 30-minute flight time. But again, like I mentioned yesterday when we were talking about drones in the previous event, with taking into consideration safety, right? You're not flying it down to 0%, which is where you're going to get 30 minutes. You're getting 25 minutes maybe of flight time, 24. But a battery is small and it costs a fraction compared to an M210 or an M600. And you can pack it into a small enterprise case, so you can go out in a day's work inexpensively with that 20 megapixel sensor. One thing that I did want to, I'll bring up to show the folks tuning in here, our educators. I just shared the wrong screen, I think. Is a software for taking all these images, because what I've seen initially and trying to work is just you end up with a lot of data. If you go out and you take pictures of these lines and the amount of poles, just talking distribution, what do you do with all this data? So for the folks tuning in out there, this is a software for you to be able to take those pictures, and Garrett mentioned GIS, being able to take the imagery, roll it into an inspection and tie the lines together, because these images are geo-tagged. So if you have them in a certain area, you can find your assets. And companies, you know, the poles locations are known. So you put this stuff into a computer and you can roll a right-of-way inspection where you've got the pole and you've got the photos associated with that line. And it's inspectable. But what I want to show here is where you really can't see when you're just flying along. And I know, Garrett, you've seen this example. But a pole right here where you've got clearly burnt up, you're getting a loss of structural integrity. And this isn't something you'd see from the ground, and maybe you'd have to put someone up in a truck. So using a Mavic 2 Pro, you're able to pick out things like this, and you can roll that information into a software that is going to allow your pilot might not be the person doing that inspection. So I'm going to stop the share here. Your pilots might go out and fly and collect the data. You then take that data and you're putting that data either into like a Pix4D, a drone deploy, or some type of internal company software, so that you can now share it with the decision makers, the crews, the linemen, the folks that go out there and are going to knock those jobs out. Is there anything, just off looking at that, anything any folks want to add?
I was just going to say, you're kind of speaking to what is the kind of the immediate value to that data in being able to find problems. But, the real purpose for the program here at Duke is really we're going out to try to collect attribute information. What kind of fuses are on a pole, what gauge wire, what kind of transformers. And really the driver there is that all of that data drives decisions on how we can make updates to the grid. So, if we know all of those things and we know the accuracy of that data, there are other studies, computer automated studies that we can run to basically determine where we can put newer equipment out to give us the most bang for our buck. And that really, the purpose there is to, keep the power on as much as possible for our customers, and then to also provide an energy savings back for us to where we almost don't have to produce as much power for the load that's being required. So there's a lot of second order effect that you get collecting that kind of data outside of just finding issues. It's also kind of a long-term future state type thing.
Like an archive, basically archiving the system. Right?
Correct.
Okay. Now, where we don't have any questions coming up in the Q&A, I see that the chat was somewhat active. So if there's any questions regarding the hardware, software, anything, go ahead and throw those into the chat. I would love to dive into like the BV loss and things like that, but just because of the setting, you know, for this webinar in regards to how we've set things up and what we're discussing, we're just not going to be able to jump into that today. And kind of with where things are at, I guess we can move into what skills or what jobs maybe currently and in the future are looking like within the different organizations, and not necessarily a job as like a drone pilot, but someone who has a Part 107. What are the skills that they need in addition to just having a Part 107 that are going to, you know, help them within this industry? What are the kinds of things that educators can be, you know, also implementing other than just that basic, you know, 107 NAS airspace, like the test book questions? What else is important? And Corey, can you?
Yeah, I got one for you. Understanding the, I guess, photography triangle. So a lot of people don't think, you know, they think that these drones, you put it on auto and let it run and it's going to take the best photos for you. And that's not necessarily true. You really need to understand ISO, understand shutter speed. You know, that those are things that are important to being able to take good pictures. And that's something that they can teach with all of their smartphones that they have. You know, every kid that shows up to class in high school's got a smartphone. Break that out, put it in manual, and start teaching what ISO, shutter, and shutter speed and aperture is. You know, like that's I think really valuable for doing what we do. Not a lot of folks really understand that. Other than that, you know, these kids today, they got their video game skills. So getting out there and learning what we do, I think starting to teach that safety mindset. You know, if you're teaching Part 107, I'm excited to see schools teaching the 107, you know, safety mindset or safety, I guess the 107 path. I think the main thing and the number one thing to understand is the reason that exists is due to safety. And so making sure that you know, they have that safety management culture, the aviation safety culture, that we're not going to take risks. We're going to do the right thing. We're not going to fly over people. We're not going to, you know, fly over the football stadium to catch a cool picture of the high school football game. You know, like it's all about, you know, being safe. So I think those are a couple things that they could give. That's what I'd like to see my candidates have.
Yeah, that's excellent. And seeing from the chat here, folks are amen that. So thanks.
Yeah.
John, what would you say? I mean, in regards to you know, the future and like for companies like Halifax to be able to kind of build and grow their program, what are those skills that folks will have to have?
The thermal imaging is going to go a long way with all the solar farms that are going up everywhere, and also the inspections. I mean, we used to take line crews and inspect miles and miles of line. Now we can just do it a matter of sitting in the truck seat and flying right of ways. So I mean, in the Part 107, when I got my Part 107, it was, you had to search and search and search for stuff to you know, to pass, because there was no training tools out there. Now I reckon they teach them in schools now. So, you know, there's a lot of tools out there you can learn the Part 107 now.
Yeah, that's like I guess both of you are saying, you see that the Part 107 is coming into the schools. That's a really significant certification. I mean, to pass that, it's a federal certification that you can have. And I liked what Corey, you said about taking out your smartphone. They all have phones, and put it in manual mode. And John, for you to come back to that thermal bit, you can get these thermal cameras that you can attach right to your cell phone. And it's not a drone with a thermal camera, but as Garrett mentioned earlier, it's understanding, and what Corey was hitting on, the elements that what you're actually looking at, how it works, the emissivity, the exposure triangle. Corey, speaking to that exposure triangle, that's one that they can really teach with the equipment that they have, a Phantom 4 Pro or a Mavic 2 Pro, because you can change your ISO, aperture, and shutter speed. So figuring ways to have students get different exposures and play with that is really something that they can do. Garrett, what would you say in regards to current jobs, future jobs, and kind of the skills?
Yeah, no. So I'll steal a phrase that a former boss of mine used to use a lot. First off, we're looking for good humans, and really, that kind of encompasses a lot of things. But people who can show up on time, be professional, have a learning mindset. People that you want to work with on a day-to-day, because so much of what we do is so tight-knit. You're working with a crew member. At least on our projects, we're in a crew. It's not just a pilot. We always fly with a pilot and a visual observer. And then I would say, really, Corey, I think you hit it. You really hit it with your statement on, aviation professionalism and kind of having that understanding of safety management and understanding kind of why utility companies drive the safety side of this and why it's so important from a brand standpoint and a customer standpoint. But also, we have to be responsible members of the airspace community as well. And, Corey's company, the company that I work for, we also have helicopters, and we work very closely with those assets as well. So we're not the only people out there collecting data. There are things that, we use a helicopter for versus a drone, because the business case just isn't there with the drone technology yet. So that is really crucial to have an understanding of that.
And having that background, right, that aviation management, the SMS, the flight ops manual, this comes secondhand. And that's kind of where, with my background as a manned aircraft pilot, have been able to take 910 drones, is like, we understand this inside and out. And it's great for schools, right? Local schools, and these teachers to be able to connect with folks that have that solid, strong understanding. What you hit on it, Garrett, when Corey was talking earlier about the safety mindset and culture, you hit it, I think, just as well. CRM, right? In manned aviation, we call it cockpit. I'm gonna mess that up, but
cockpit resource management, crew
yeah.
resource.
I'm like, it did it. I've heard CRM so much that the cockpit resource management didn't even make sense, and I haven't been in flying, a manned aircraft recently, but yeah, the crew resource management. And that's another thing that educators can do in schools, because you don't have enough drones, right? If you have 16 students in a class, you don't have 16 drones. And even if you did, it wouldn't be safe. So maybe with the way that the talks have gone and under 107, you can only operate one drone at a time. But in the school environment, we're seeing some, exceptions and policies coming into play. So if you have a limited number of drones, but more students, you've got to put them into these roles. And this is what we do with our online remote pilot academy, where we're kind of engaging with students through this coronavirus. Is one student's the pilot, the other student's the BO, and then the third student's maybe like the mission planner. And that mission planner has the authority to kind of end anything at any point, right? And any of them could stop at any point, but like that mission planner has like the final say-so. But then you can kind of rotate through, and they have to work on communicating together. So can you Garrett, touch on that just a little bit more, how the operations are conducted, where this is never one person going out.
So Duke Energy's policy is all of our operations, they have to have at least 2 persons on the crew, and that may look like a remote pilot and command and a visual observer, or a remote pilot and command and a payload operator. But it's always 2 people, and the crew resource management piece of that really plays into that, and that's something that you learn at a very young age. The fundamentals of crew resource management, just being able to work with another person, being able to work through conflicts, in an environment where 2 people have to make decisions about what you're going to do. That's a very real thing, and that all plays into especially with like a distribution product, wire strike avoidance. We have a lot of call outs and checklists and things of that nature for wire strike avoidance when we're flying really close to the wire environment. So we do a lot of things in UAS that we also do in utility helicopters. If you were to kind of participate in both of those organizations at Duke, you'd see a lot of similarities. And so we try to keep the professionalism level of what we do in UAS at the same level as we do in manned aviation.
Awesome. I think because, like you talked about that manned aviation, the Part 107 is a very, very new certification. Like, it's in its infancy. If you look at like what the Part 107 is in the entire 14 CFR code, it's like a sliver. And then if you look at 135, it's much bigger. And as drone deliveries become more prevalent, as BV loss, some folks want to talk about, become more prevalent. Not going to try to say the word, become more prevalent, right? That 107 is going to grow. And if it's not 107 that's going to grow, something will come of it, right? And the need where you actually have to show your skills flying an aircraft in order to get that certification. So what, I'm going to ask, is anyone familiar with Corona cameras that's on here?
Yes.
Using Corona cameras. Okay. Do you just want to
Garrett said in the chat, we fly them on our helicopters, and we've investigated flying them on drones, but really drone technology, at least in the Part 107 world, isn't quite there yet to carry that kind of load for any kind of long amount of time, because as battery technology, the bigger you make the batteries, the bigger you have to make the motors, the more battery power they use, and then you wind up with about a 30-minute flight time, no matter how big your drone is. And the more you pick up, the heavier things are, the less amount of time you have to fly them. So when you're flying a $100,000 camera, you really want to put it on something that's got a lot of flight time and a lot of reliability.
Okay. Garrett, what would a job requirement list for an entry level position at Duke consist of or look like?
So I can kind of speak to kind of what we've seen and who we've hired just recently. So from a project standpoint, we've hired people with very little flight experience and only a Part 107 to work on that project. Example is a gentleman that we have that works on the project that's a retired state trooper. He flew drones. A lot of the flying that he did was more automated. What we do is more manual. And he had a Part 107. We brought him on and trained him everything that we needed him to know to do the work on that project. Our enterprise operations folks who do kind of a wider set of skills, they typically have a degree, whether it's 2-year or 4-year, and some kind of aeronautics or aviation background. So that's kind of a general answer for maybe 2 different situations there.
All right, right on. We had some folks, and we're kind of just moving into a little bounce around question and answer here, still kind of covering skills a bit. And I'm losing my place here. But I wanted to touch on this because this chat was going on in the chat versus the questions, and maybe Corey, Garrett, John, maybe you guys might have talked about it. But in regards to like women within the industry, within Southern Company, Duke Energy. I know Halifax EMC, like John, you guys aren't like running this full large program as far as having pilots, but I mean, Corey, what are you seeing in regards to women in the industry?
Yeah, so we're making an active effort at Southern Company to support, organizations that do what they can to support these young women in engineering and that kind of thing. So there's actually a women in engineering organization that we do a lot of work with. We do ladies in aviation days with Delta Airlines at Hartsfield Airport and that kind of thing. But we're actively going out and kind of showing our technology and preaching the UAS gospel and showing gaining interest. Is it lack of interest due to lack of opportunity, or is it a lack of opportunity due to lack of interest? So we're trying to create that interest so that we can create those opportunities.
Yeah, that's awesome. Garrett, yeah.
Yeah, I'd say, diversity and inclusion is a huge thing, for Duke Energy. And I think just the climate and environment that we live in today, you're going to see more and more of that. And I think it's a very relevant, important topic. So, we're constantly looking for opportunities, to hire qualified individuals who have a desire to learn and a desire to fly. And I can tell you just personally that having flown with women in the industry, I made the comment earlier in the chat that some of the best pilots that I've ever worked with were women. So it's definitely not, a male only type industry. There are plenty of women that are out there doing it alongside of us. So.
And I would say, because of my experience in the manned aviation industry, having gone to Embry-Riddle Aeronautical University, it was over 70% male. But at that point, I think with college, it's not a matter of it's interest. Like, was the interest there? Was the opportunity for interest to develop ever even there? So one thing that 910 Drones has done locally is afford just women, or not women, but girls drone camps. Because what I've seen from having been in the industry and working maintenance in the military is that sometimes girls aren't going to want to engage in a certain activity if there's, boys around. So being able to afford, the younger girls that opportunity to decide for themselves without having to worry about outside stuff. And when you see these groups of girls get together around drones, I mean, it's amazing. It's excellent. So I think for those high school teachers that have the girls in your class, being able to really allow them to figure out, do I have the interest or not, while not being put under the eyes of the boys. So yeah, I think that's great. And I think like what you both mentioned, there's women in drones. So I forgot who was kind of asking that, but Women in Drones is an organization that does just that within the industry. They're promoting those opportunities for girls and young women and women of all ages. So that's great. Now, I've been paying too much attention to this great conversation. I'm going to look over here at the questions and see, is there anything that you guys have been seeing or kind of engaging with that you want to touch on?
I think I can talk a little bit about the BB loss, gas-powered UAVs, and LiDAR. I can put it all into one quick statement.
Let's do it, because we've got folks here, like these teachers that are going to talk to students. We need to put that in a thing so that we don't just shush it aside. So that's great.
Okay. So here's a future use case that's going to apply to a lot of the things that you guys are seeing. So Part 107 is a great place to start. Part 107 is not the drone that we can fly for 10 hours and fly it down the road, or launch it from Raleigh and fly it to the coast to survey some storm damage. That's going to take something bigger and something with more capability. So now we're stepping into the manned aviation world with Part 135 and Part 91. And that's the Group 3 drones that weigh up to 600 pounds, that have 100 pounds of payload. And those drones can fly with multiple sensors. So picture this. This is future. In the future, we've got a hurricane going to impact the North Carolina coast. We would launch a drone and then fly to the coast and map that the same maps, in the same way that I showed you with the drone deploy map. And then once we map that, and we're talking large areas because we're flying a much bigger airplane that can stay there much longer. Once we map that, we recover it and then wait for the storm to impact the coast. Right after the storm hits the coast, we go out and fly it again. And then we use change detection software, which is still under development. This is the kind of thing that kids can get excited about and think that they can go out and invent, because they can. But this change detection software would identify where we have lost poles and trees and we've got flooded right of ways and that kind of thing. So I don't believe, while I think 107 is always going to have a part in the drone industry, I think for disaster recovery, disaster management, and really long distance line patrols to replace helicopters is something that we're not going to see until we can get beyond Part 107. So,
or would you say like a Part 107 with that BV loss rating, and that's where we could just dive into the dirty?
Well, I think yes, I think Part 107 with the BV loss rating is going to be fine, and I think that's going to come in the future. And that BV loss rating will have applications and really provide some capability.
Yeah.
But it's not going to provide that over the horizon, long endurance, 24-hour operation type of application. I think you could maybe do some line patrols or gas line patrols or something like that, but just due to the battery technology and the 55-pound limitation, if they could increase that 55-pound limitation, I think we could do a lot of things safely with a drone that weighs more than 55 pounds.
And I'd say that's exactly where we're at, because you have your SUAS rating. So you got your ability to fly anything below 55 pounds. Not that folks aren't flying things over 55 pounds, it's just uncommon. Kind of like when aviation started, maybe like instrument ratings weren't something that were just given out, right? It was like individual basis. And then it became, the equipment developed, the ability to have the navigation through instrument conditions was more acceptable, right?
Yeah, and I think UTM is our first step towards that, at least for the small drones, maybe even for the bigger ones, but I think the bigger ones will fly under manned aviation rules. But yeah, the smalls and UTM go right. And what I'm talking about UTM, that's Universal Traffic Management, and or Unmanned Traffic Management, I'm sorry. And that's identifying the drones that fly in the airspace so that we can keep them from running into each other and running into airplanes.
Right, because as we have more companies, utility companies, just them leveraging the drone technology, and then the drone delivery companies, and then you have the pilotless man taxis, which for the folks that are part of the DPI from yesterday's webinar, we covered delivery drones and pilotless air taxis. You start bringing all these into the equation, and it's like, it's going to look like the Jetsons. So there really has to be some way to, not contain or control, but safely have everybody fly together. So that's awesome. At this time, just want to go ahead and just go around the group and give each of you a moment to kind of wrap things up based on what you heard. I'll just quickly go through. We talked about in the beginning the different use cases, substations, distribution, and Corey started showing us about the modeling ways that we're using drones. We talked about the hardware, software, Phantom 4, Mavic. You guys said the Matrice 600 that you're flying with the 100 megapixel sensor, and then we kind of just talked about the different skills. So Corey, if you want to go ahead and just kind of give us some final thoughts and where educators maybe can take what they learned from here.
Yeah. So I just saw a comment in the questions based on is automation going to make all of the Part 107 pilots irrelevant? No, that's not exactly what they said, but to paraphrase. I think the future is automation, but I think it's going to be 3 phases of automation. With the large drones flying, that's going to be a mostly automated flight, but someone's going to have to build that flight. Someone's going to have to program the aircraft. Someone's going to have to maintain the aircraft. Someone's going to have to be available to, just like flying an airliner, they're going to have to be there to take control of it if something happens, So there's going to be plenty of work out there once that line of work opens up. And I think that's going to be a good place for people to go that may have prior medical conditions that can't get you know, a first class medical certificate from the FAA, they could still sit on the ground and fly a drone. You know, I think automation will have a part, but I don't think, I think this is a very viable career field for the future, because this is, I think unmanned aircraft systems are the biggest thing to happen to aviation since airmail. You know, airmail is what developed our current air traffic control system, and all the VORs and all of the navigation aids that we use today were all developed because of airmail, because we needed to get a letter from New York to California real fast. And so I really think this is going to have that same type of impact on aviation. We're talking unmanned air taxis. We're talking unmanned cargo flying, you know, transatlantic. We're talking like we did in Puerto Rico. We pulled 72,000 feet of rope for a wire with a drone in Puerto Rico, and Duke led the way with that there. We actually tried to copy him, but we told him that we beat the Tar Heels. But no big deal. But yeah, we totally went. That's really become. We're doing work with these drones. We're
Yeah.
It's so amazing. I'm so excited about it.
That's great. And you said it, like, not everyone in the teachers here within North Carolina, they're going to see that every student that comes in, they'll be able to get their Part 107, but they might not be great on the sticks. And their interest in drones is not going to decline, and there's opportunities for them. And having a Part 107 is going to make it easier for you to get in the door as a data analyst for these types of operations and things like that. So,
oh, for sure. Yeah.
Thanks, Corey. John, I just want to go to you next. Just kind of tell us your final thoughts here in regards to the education piece, whether it's thermal or what you kind of want.
Well, I think it's all of it. I mean, it's so many fields, so many areas you can cover with a drone. Practicing, I mean, with a drone. I mean, Part 107, that's just a piece of paper. You know, it's having a drone, flying it, getting experience. Thermal imaging, that's looking at thermal imaging. I mean, you knowing the technology behind it, but also getting the experience from looking at images and, you know, knowing the difference when you see it.
Yeah, that's great. So when they, like I said, they saw these NIST training video, for those educators to be able to put up those buckets, put up different obstacles, and really have those kids work on those stick skills and understanding that tech, and look into maybe one of those phone camera thermal imagers. Garrett, I'll go to you to have the last of the roundup here.
Yeah, and you know, I kind of want to chime off of what Corey was saying, and you know, when I saw that last question pop up, I thought that was kind of a perfect way to close this out, and I agree with Corey. I think you know, everyone as history goes on is going to have to be adaptable. Things change. Our utility aviation is kind of going through that right now, where we used to do a lot of things visually from an inspection standpoint. Now we're starting to fly advanced payload balls on our helicopter, and that's a totally new thing. You know, for us, you know, and that's just an example of manned aviation adapting to kind of what's going on right now, but that's going to happen to UAS as well. And what I would say is, you know, we're kind of talking a lot about people flying the drones, and I think that they're, like Corey said, there's going to be jobs. They may look different, you know, 10, 20 years from now. It may be a different type of job, but there's still going to be those jobs. And I think the other important thing to realize is there are also going to be other opportunities within the ecosystem, whether that's business development, project management, you know, software engineering, you know, cybersecurity, all of these things that are going on in the world right now. And from a career standpoint, there's going to be a part to play in drones with those types of careers where, you know, I'm already seeing, you know, project management on a large scale for UAS here at Duke, you know, cybersecurity jobs related to UAS. And so, you know, there's a lot more to this industry than just flying the drones. There's going to be a lot more opportunities than just the piloting aspect of it. So,
yeah, thanks, Garrett. And to just make a last point that we didn't touch on, but the educators tuning in, they got introduced to the Kitty Hawk fleet management. So when you start building out these large programs for utilities and inspections across multiple states, just managing a drone fleet becomes a position in itself. So yeah, that's great. Thank you, Garrett. And thank you to all of our panelists. Thank you, Corey, Garrett, and John, for coming on today, giving your time and attention to our audience. Thank you to everybody who tuned in. If you have any questions, you can reach out to the folks that you see here. Connect with people on LinkedIn. That's one point I didn't make yesterday with the folks with the North Carolina Department of Public Instruction. If you're going to be instructing 107 and talking to students, get on LinkedIn. That's where you're going to see a lot of information about what's happening in the industry, and connect with the different folks that you see here and ask questions. So thank you everyone for your time. I will see all the NCDPI instructors tomorrow during our mapping and modeling webinar at 11 a.m. Other than that, everybody have a great afternoon, and thank you to all the panelists. Have a good one, everybody.
Awesome. Talk to you later.
Yep.
Thank you.